So now I'm going to have a look at 2013, and this is part 10b. Now we start off with the same idea, but there's a second bit here that we have to pay attention to. So it says a particle starts from rest at a point O at time t is equal to 0, and it travels, so this is point O, it travels along a straight line with an acceleration. So here's its straight line. It's an acceleration this time, not a deceleration, and the acceleration, it tells me, is 24t minus 16. T is the time measured from the instant when the particle is at O. You've got to find its velocity and its distance from O at time t is equal to 3. Okay, so this is my expression. A is equal to 24t minus 16. I'm looking for its velocity first of all. So, limits I'm interested in. I'm looking for velocity. I want its velocity in terms of t, so I want dv and t. Those are the two I'm after. So at time 0, velocity 0. And after 3 seconds, what will the velocity be? So that's the first thing I've got to find, the velocity after 3 seconds. Okay, so start with the expression. A is equal to 24t minus 16. Of course, that doesn't match my variables, so I'm going to change that acceleration into dv dt. So dv dt is equal to 24t minus 16. I don't have to separate the variables. I don't have to accept the dt. So 24t minus 16, and I'll make that a dt on that side. Okay, I'm going to integrate both sides. My velocity is going to go from 0 to v and 0 to 3. So rather than write 0 to v and 0 to 3, I'll say v to 0, 3 to 0. And now I'll integrate. So when you integrate dv, which is just 1 times dv, you get v, is equal to, this of course will become 24t squared over 2 minus 16t. So my v, remember, is going from v to 0, and this is going from 3 to 0. So I'm going to put in the limits. So v, going from v to 0 over just v, this would be 12t squared. So this is 12 times 3 squared minus 16 times 3, and of course the second set of the limits will be minus, putting 0 in for t, which would just be minus 0. So this becomes, v is equal to, when I work that out, I get 108, 12 nines, 108, minus 16 threes are 48, so I get a v of 60 meters per second. Okay, so that's the first part. It says find its velocity and now find its distance. Okay, so again, back to these ideas. So velocity, t, we're going from 0 to 3, velocity is 0 to 60 now, and the distance, so the matching distance is 0 to s. Right, I've got to, in order to get s, I'm going to have to pick, go back to the beginning. A is equal to 24t minus 16. I'm going to decide in this particular case if I'm looking for s, which variables will I use? So obviously, or which expression will I use if I want to get these variables in? So obviously this is the best one here. So instead of a this time, I'm going to put in v dv ds, and that's equal to 24t minus 16. Now, when I put in v dv ds, I can now see I've got 3 variables, v, s and t. And there's no way I can solve this with 3 variables. So remember what my options were. A is dv dt and A is v dv ds. So none of these are doing me now this time. So I've got 3 variables. Right? So if that happens, if you get 3 variables when you're trying to solve, go back to the velocity expression that you found in the first part of the question. It will always be in the first part of the question. So you go back to v. So my v, before I put the limits in, okay, when I integrated and before I put the limits in, v was this. V was equal to 12t squared minus 16t. And then I put the limits in. If I hadn't put the limits in, I would have had to use a constant of integration. So that's what you do. You go back to the expression, you don't use any limits, and you put in a constant of integration. Now it's v and t, they're the two things I have. So I have a look at your initial expression here for v and t. So your conditions at the very beginning were that v was 0 and t was 0. So if I put v and t in for 0, this will just give me that c is 0. Remember, I'm putting v is equal to 0 and t is equal to 0. That's where I get c is equal to 0. So this really becomes v is equal to 12t squared minus 16t. Now this time I'm looking for distance, so it's easy for me to change velocity. Remember, velocity is ds dt. So I'm going to change this velocity into ds dt equals 12t squared minus 16t. I'm going to separate the variables and I'm going to integrate. And then I get a really nice expression. So when I integrate this, and the limits I'm looking for are 0 to 3 for time, 0 to s for distance. Or if I turn them both around the same, the other way, that's fine. But once I am consistent and turn them both around. So s to 0, 3 to 0, s to 0, 3 to 0. And let's integrate. When we integrate ds, we just get s. And when we integrate this fella here, 12t, this will become 12t cubed over 3 minus 16t squared over 2, which of course means that s is equal to 4t cubed minus 8t squared. I'm going to put in the limits, s to 0 and 3 to 0. So this will become s equals 4 times, so that's a cube, sorry, not a square, cubed. 4t cubed, which of course will be 27, minus 8 times t squared, which of course will be 9. And we work that out, you get 36 meters. Okay, now we'll just finish the next part of that. The second part of that question, I'll just get a piece of paper. So the second part of that question says, using that same expression now, find the value of t when the speed of the particle is 80. Okay, so find the value of t. Find the value of t when the speed of the particle is 80. Remember, we knew what t is, what v is. V is 12t squared minus 16t. So 12t squared, v is equal to 12t squared minus 16t. So I'm going to use this expression here, and I'm going to put in limits. Now my limits are, remember, that the velocity from 80, it started at 0, it's going to go as far as 80, and the time, now remember time started at 0, and we don't know what time it's going to take for it to get to 80, so we're just changing those limits around a little bit. And I'm just going to put in the values, and it's already been integrated, so all I'm doing is putting in the limits. So this becomes 80 is equal to 12 t squared minus 16t. I might just divide all the way across by 4, get a nice easy equation. So 20, I can see I'm heading towards a quadratic. 20 is equal to 3t squared minus 4t. If I bring that all to one side, that will give me 3t squared minus 4t minus 20 is equal to 0. I can solve for this using your guide and target, or if you really want to, your minus b equation. But whichever way you use, you're going to get a t of 20 over 6, 10 over 3. So that's the time it takes to get to 80 meters per second. That's that part of the equation. Okay.